As you may already know, the Earth's crust is made of rocks. If you look closely at a rock, you will see that there are many different bits. Some bits are dull, whereas other bits are rather shiny. The main idea here is that all these components occur naturally. In other words, they are not made in a factory or by a human being. A naturally occurring element or compound is known as a mineral. Ore is simply a rock containing a high percentage of a certain mineral. For example, hematite contains a high percentage of iron. The extraction of iron from hematite is done in a blast furnace. Malachite contains a high percentage of copper. Cinnabar contains a high percentage of mercury. We can think about an ore a bit like a chocolate chip cookie. We really want the chocolate. If there are more chocolate chips in the cookie, then the extraction process would be more economically beneficial. As more minerals, in this case, the chocolate can be obtained. If there are fewer chocolate chips, then the extraction process may not be as economically beneficial. For the most part, the minerals are oxides, carbonates, or sulfides of the metal of interest. Some ores of nonmetals include quartz, which contain a high percentage of silicon in the form of silicon dioxide. Limestone is also an ore. Can you remember what is found in a high percentage in limestone? Pause, think, and continue when ready. The answer is calcium carbonate. Limestone contains a high percentage of calcium, but calcium exists as calcium carbonate. The iron in hematite is mostly iron 3 oxide. The copper in malachite is mostly copper 2 carbonate. The mercury in cinnabar is primarily found as mercury 2 sulfide. The extraction process for each ore can vary, but the key idea here is that the mineral must be present in a high enough percentage, or else the process would not be very economically beneficial. Now, before we can extract a selected metal, we must first consider its reactivity by looking at this reactivity table. The most reactive metals are at the top of the series, and the least reactive at the bottom of the series. Although carbon and hydrogen are not metals, they are still included in the table for comparison purposes. A more reactive element can displace a less reactive element in a compound. Can you remember what this type of reaction is called? Pause, think, and continue when ready. The answer is a single displacement reaction. So to extract a metal from an ore, a single displacement reaction must occur. We can mimic the extraction of copper from malachite using copper 2 carbonate powder. Copper 2 carbonate is a green solid that thermally decomposes to form copper 2 oxide and carbon dioxide upon heating. Copper 2 oxide is a black powder, and believe it or not, we can actually extract copper metal from copper 2 oxide. Place 3 spoonfuls of copper 2 oxide in a crucible and 1 spoonful of charcoal, which is essentially carbon. Heat this using a Bunsen burner with the crucible lid slightly ajar for approximately 5 minutes. While that is in progress, why don't you grab a piece of paper and a pencil and predict the products of this single displacement reaction. Pause the lesson and resume when ready. The carbon displaces copper in copper 2 oxide to give copper metal and carbon dioxide. Remove the crucible from the Bunsen burner and empty its contents into a beaker of cold water. Pour out the water and charcoal, rinse with water and repeat. This must be done when the mixture is hot, or else copper 2 oxide will reform. You will find little bits of copper metal at the bottom of the beaker. You have successfully extracted copper metal. In another lesson, you will learn how to extract iron using a form of carbon known as coke. Some metals, such as gold and platinum, are not found in ores, but rather exist naturally as native metal. Note that these are less reactive metals and therefore do not form oxide, sulfide, or carbonate compounds. In summary, an ore is a rock that contains a high percentage of a certain type of mineral, which can exist as an oxide, sulfide, or carbonate compound. The mineral can be extracted by a single displacement reaction using a more reactive element.